Well, hey everybody, welcome to exam prep night. My name is Paul Abernathy and there's the bell. So it lets us know that we are definitely involved in exam prep night. Hopefully you've had a chance to make it here. Hopefully you're preparing for your exam. You either have taken it already or you've already passed it and you're just joining me because you enjoy exam prep, or you really are studying for that exam and you're taking it in the next couple weeks, maybe in the next month, maybe in the next 2 months, and you need to hone those skills. So as the title says, we're going to be talking about the Fast Tracks program exam prep. So we're going to be looking at specific questions in here. Now, from time to time, I like to dig into the questions that are in what's called our competency test. And there's certain questions, I have them written down here of different ones, and I keep data logs. So a couple of things that you might not know, and I'll explain a little bit for those that are new, that haven't done this before. I typically keep track of all my students. So what I do is I monitor how they're doing, when their scores are low. So if you're in the Fast Tracks program, just so you kind of know how it works, and we'll go over some questions tonight. Some of the ones that some of them they find more difficult, and it might be just because of the wording or whatnot, and hopefully it'll help you. But the first thing I should say before we do all this, if you're new to this channel and you've never been here before, make sure you subscribe. And make sure you share it with other electricians. Go out and tell electricians there's a place they can go and talk code. And again, every Saturday night we do Electrician Live. So hopefully you check that out as well, because we talk just about anything electrical. But when it's Electrician Live, we're really not talking that much code. Every now and then we might. But this is the night. And you probably heard that in the start of the first of the year, there is a possibility that these Wednesday night chats will end for the open public, and it'll be only to my paid members that are members of our YouTube channel. But we're not there right now, so you get the beauty of joining me for this stream. But I'll remind you, if you're studying, we have literally thousands of hours worth of material already up on our YouTube channel that you can listen to and watch. Okay. So again, like anything, business is business. And so, I'm under a lot of pressure to, not quote, give away the free stuff anymore, but, I'm still fighting it. Some of you might have noticed that the prices went up for our Fast Tracks program, in our other programs, but okay, look, so what happened was my board of directors agreed at that meeting to raise the prices. But there's something that they didn't agree to, and I didn't say anything during the meeting. By them raising the prices, it allowed me to be able to offer discount coupons. And that wasn't in the bylaw. So I can offer a coupon that brings the price back down, and I do it at my own leisure. So from now and then, I'm going to be offering specials, coupons, things like that. So make sure you subscribe if you're interested in that. Okay, so that is not. Now, I'm probably okay until our next meeting when they try to do that, but we don't change that for a year. So at least they can't do anything about my giving away coupons. So, that type of thing. Now, I am the CEO, so again, I have a lot of say in that director, but I agreed to give up a certain amount of control to the board. So, but I had a way around it, and I still have a way around it. So, anyway, they're not going to like it, but I don't really care what they like. Okay, so welcome some people to the stream. I've got it on Facebook tonight as well as on our YouTube channel. So I see you, Tim, Elwood, Fancy Pants. Thanks for coming over on our Facebook. I see there's Shane and David liked it, but I don't know if there's anybody in the chat. I can see it if you chat, so let me know who you are, where you're from, and that's where you're going to type in any of your questions you might have or anything you want to ask about the exam prep and things like that. So again, I see the different people in the chat. So again, thanks for coming. So we're gonna dig into some stuff. Again, if you're shy and you're in the background, don't be. You're among family. Ask any question you want. Hopefully the audio is coming okay and I'm not overmodulated. Now, if I am, I'm sure, hopefully Tim or Elwood will, especially Elwood, he would let me know. So, hey, Fastened up Oklahoma. Thank you for coming. Thank you for coming. All right. So if you're new to the fast tracks or the concept of fast tracks, there you go. Fancy Pants, California. You have my condolences. You and your 55 electoral votes. Anyway, so a lot of Fast Tracks program is a structured study plan. We're going to use it tonight for those that have never seen it before. Because everybody knows I'm a big believer in studying with a purpose. You got to have something to study with, some purpose. And flipping through the code book's not going to do it, right? So that's when we created the Fast Tracks programs. Nothing unique. It's just an interactive program where I'm allowed to grade your work, give you feedback, and you learn reading comprehension by reading the question. You can listen to it as well. But you really have to think about it. And some of these questions will trick you up. We're going to look at some of them today, but it's rare that I open up the competency review questions to the general public. So again, I've done it a couple times. So we're gonna do it tonight. But again, the part of this event here is for you to ask questions as well. If you have any question, I'll do my best to answer it. As I tell people, I am not a know-it-all. I don't claim to know everything. So, I learn every day just like you do. The one thing I do have a passion for is helping you, whether it's through my courses or through the phone calls I get, is helping you pass your exam. That is a passion of mine, okay? All right, so we're going to look at some competency reviews tonight. So let me go on and go to one, and we'll go on and get started. Hey, Moise, I see you up there and over on the East Coast in Maryland. Okay. And thank you, Tim. I saw loud and clear, so everything looks like it sounds good. All right, so the first one that we're going to look at, and again, if you have any comments or anything that you want to say, please feel free to. You can see the top of the screen, and you all can see your own chat. I have at the top of the screen so that I can see what's being asked without having to change my screens. And I'll do my best to try to position it so you can read it. So one of the things about our competency review, if you're in the Fast Tracks program, is the whole reason we have competency reviews, to be honest with you, is so that I can validate that you, one, used the right code section, and two, you came up with the right answer. Now, when I'm grading them, sometimes you might have the wrong code reference or something similar, but if it resulted in an accurate answer, I'm going to give you the benefit of the doubt. Okay, I'm going to give you a little bit of the benefit of the doubt and work through that. Okay. But most of the time, when you start getting up to about unit 7, 8, 9, 10, 11, 12, and 13, I am really going to pay a lot of attention to make sure that you're using the right code reference. So people ask what was the reason for our price increase. It is literally the amount of time that I personally have to commit to it. And for all of those that are upset about the free stuff thing, you have to remember that I actually charge the company for my time on here. So it's free to y'all, but it is not free to Electrical Code Academy. I actually bill my time, and I don't know if y'all knew this. I bill my time, and we're a corporation. So that's how I bill it back against the company to get paid, because I don't take a salary. Okay, I have another job. So as I created and hired other people to help me, I had to find a way. So when I do my videos or I do my stuff, I actually bill the company. So if you ever wondered that's why I do it. And so because I bill them, that's why they're harping on getting rid of the free stuff. So again, don't kill the messenger. I'm just trying to do my best with what we've got to work with. Okay. All right. So I spend an awful lot of time grading stuff in our residential, our commercial, our industrial, our grounding and bonding. Those are very intensive programs to grade. And Fast Tracks can be as well if I give feedback, things like that. So again, time is time, and you got to account for it. So, but I do appreciate all of you that come and join in. And again, hopefully you get something out of these. And remember, I've got literally hundreds of hours available for you to go watch. All right, so we're going to look at a question that comes up quite a bit. It's a very simple question, but it routinely, I would say, of 10 students, believe it or not, 10 students, 8 of them get it wrong. And it might seem simple, but they get it wrong. And it's a simple pull box calculation, okay? A simple pull box calculation. Now, a couple of things to remember. We're going to do number 3 on the screen, so hopefully you see it. And this is a simple pull box calculation. Notice that there's no conductors. You have no idea which way the conductors. Now, there are some people out there that'll tell you that they've got to show you the conductors. I tell you that they're full of crap. They're not pure educators if they're telling you that. They are real world people who know that in the real world, you got to have conductors in order to have an understanding. In an exam world, they can ask you questions based on an empty box, just like you see on the screen. And you have to think of the plausible concepts of what the sizes would be in the, quote, what if scenario, okay? So that's what we're going to do. We're going to do some of these questions. They're not all calculations tonight because, as y'all aware, I do have a calculation seminar coming up on November 21st. If you're interested in it, go check out our website. Go to electricalinstructor.com and you can register for that if you're interested in learning about all types of calculations. So anyway, so look at this box here. Now, as a student, you're studying for the code. You notice that this is asking you the minimum dimensions for X and Y, the drawing below on the screen. You don't overthink it and say, well, okay, well, what about this or what about that, or what about the distance between raceways and all that? Remember, the question didn't ask that, so don't assume that. Now, if it was a question that did show conductors, okay, then I might have to assume that, right? But it doesn't. So in this case, I don't know if they're angle. I don't know if this is a common with this one, so I have to have a separation between these two. I don't know that. What I do know is I've got a trade size 3 and a trade size 2 on the west side of this box. And on the east side of it, I have a trade size 3, and then I have a trade size 2 coming in from the bottom, right? So for those that have been in the Fast Tracks program, I'm going to give you a second to try to work this out because, again, it's all about helping you, and I want you to be honest. If you don't understand it or you come up with a poor calculation or if something doesn't work out, it's okay. Don't stress it. But I want some answers to be rolling in. Again, this is a two-way street here. This is a giver's gain. If you give, you'll gain something from it. So I want to be able to teach you to do this, but on an exam, you need to understand the fundamentals of pull box calculations. Okay? Pretty simple concept, but you have to think about, and you have to think about all the plausible possibilities here. So if you look at this question, y'all start doing your calculations a little bit, and of course, what code references are associated with this. It's important. For those that are in the Fast Tracks, you see the 2 blanks. The one on the left blank, the first blank, that's where you put your code reference. The blank on the second blank is where you put your answers, okay? So think about this box. So tell me what the minimum dimensions. So tell me what the minimum dimensions would be for an X, which is left to right. And what is the minimum dimension for Y? It's north to south or south to north. In this case, your calculation is going to be from south to north or bottom to top when it comes to a Y calculation. Okay, but then of course you've got plausible angle pulls all over the place. Okay, so in this here, we have a plausible, and I'll let y'all think of your calculations and share some with me. You have a plausible straight pull here. Okay. You certainly have a plausible angle pull. And you might be assuming that this 3 is going to go straight to 3. You don't know that. You could have conductors that come from the 2 and go up to 3, or you could have the 3 go down to 2. You don't know because we're not telling you. And if you say that an exam has to tell you, again, whoever tells you that is not a good educator. They just don't understand that I've written exams for many states, and we don't always give you the wire routing. Okay. Now, does it help? Absolutely. In the real world, will it help? Absolutely. In this fictional world of an exam, got to go with what you got. Okay. So remember what we say, and again, I'll see who comes up with the first code reference. But remember what we say, straight is 8. So this dimension here, straight, the largest raceway straight. That's one plausible calculation. And remember we said angles, angles, that's 6. So angles are 6, straights are 8. That help you any? Kind of give you kind of a understanding of where we're going. Okay. Jeff says it's 24 by 12. Jeff's pretty much already done this in the Fast Tracks program. So, I would hope that Jeff comes up with this answer. Now, Mandingo said he would just do a 26 by 26. But here's the thing, Mandingo. This is what happens in the real world. People just guess. And they end up spending more money for a box. Why do I want to buy a 26 by 26 when I can buy a smaller box that's going to cost me less? And exams are about not what I would run. Exams are about what's the best possible answer based on. And again, 26 is not the minimum. And the question's asking about the minimum dimension. So it wants the best plausible answer. Okay? Hell, I could put a 48 by 48, but that wouldn't be the minimum dimension of the box. So we always want to solve for the minimum dimension, right? So let's see here. Do I have anybody that gave me a code reference? And I'm going to look and see so that I can see if anybody gave code references. Yes, Jeff gave a code reference. So before we do this calculation, we're going to go to a code reference. And it looks like you got your code books. You're going to go to 314.28a. Nice, that's where Jeff says we need to go. So let's go look real quick, and then we'll come back. But let's go look at the code. And let's see here. We'll go to 314.28a, because that's where Jeff says that's where we need to be. Thank you, Jeff. All right, so let me make sure of what's on the screen, because again, I can't totally see the screen. Okay. All right, so what we've got is 314.28. That deals with pull and junction boxes and conduit bodies. Now, when you get to the minimum size, there's a couple things that I want to tell you with this question. So in this question, when you're doing a pull box or it gives you a calculation like this, we're having to assume that the conductors are 4 AWG or larger. On an exam, they're going to tell you, okay? They're going to tell you because you should know that if you're dealing with conductors that are less than that, 6, 8s, 10s, I'm not taking any call-ins tonight, so I noticed that my phone is ringing, but I'm not taking any call-ins tonight for the exam prep, so I apologize. So 6s, 8s, 10s, 12s, and 14s, all of those when they're in a box, that's going to be a box fill calculation. When you get to 4 gauge and larger, that's typically going to be a pull box sizing calculation. Okay, so that's going to be the difference in that aspect. Okay, so before we do our question, we got to get some answers here. Okay, so look up here. So we know that it says 314.28A1. Okay, is right here. Make sure I'm still on there. Okay, right here. So right here, this is the minimum size. It says for raceways containing conductors of 4 AWG or larger that are required to be insulated. Okay, so we're talking about insulated conductors here. All right. It says, and for cables containing conductors 4 AWG and larger, again, so cables that are coming to boxes as well is going to be applying here. We're going to have to do what's called transposing cables, and I'll explain that a little bit later. So again, this applies to raceways and cables, by the way, like an MC cable, things like that. It says the minimum dimensions of a box or pull or junction box. Okay, so you could do junctions in it, but because of their 4 and larger, again, you're not dealing with cubic inches now. You're dealing with sizing dimensions. Okay, so it says installed in a raceway or cable run shall comply with 314.28A1 through A3, where the enclosure dimensions is to be calculated based on the diameter of each raceway. The diameter shall be metric designator or trade size expressed in units of measurement employed. So we use, generally people say 3-inch, 2-inch, but it's really trade size. But does it really matter at this point in your career as you're learning it? No, it really doesn't matter. But When you see 3-inch or 2-inch, it's actually called trade size. Okay, so here's your straight pull. It says in straight pulls, the length of the box or conduit body shall not be less than 8 times the metric designator, or that trade size we're talking about, of the largest raceway. So for 8s, straight is 8. Just remember, straight is 8. Now, angle pulls. Here's where it gets a little more complicated. You have angle pulls, you have U-pulls, and you have splices. Nothing in this question is talking about splices. Nothing in this question is giving you a routing of the conductors, so we're not talking about U-pulls. And the only reason I need to worry about U-pulls is if we have a raceway that conductors are coming in and going out, and that same conductor sharing those raceways, then there has a separation you have to make, a distance between those raceways. But that also applies to certain types of angle pulls. The key here is we're triggering the 6 times. That's the key, the 6 times. Now, are there ever any occasion on an exam or in real life where you would say, well, I don't have to worry about the angle, I've got to worry about only the U-pull? And the answer to that is sure. You might have a junction box, and let's say that your raceway comes in on the right side of the junction box, and then guess what? It leaves on the right side of the junction box. That is a U-pull. But the same concept to the opposite wall is going to apply here. Okay, so just to bear with our concept here, at least for this question anyway. All right, so here's what it says for angles, U-pulls, or splices. It says where splices or where angle or U-pulls are made. Okay, so again, covering all of these, it says the distance between each raceway entry inside the box, conduit body, and the opposite wall of the box or conduit body shall not be less than 6 times the metric designator or the trade size. So trade size 3, 2. Again, it's synonymous with 2-inch or 3-inch, but us code people like to say trade size 2. It makes us feel better. And then it's of the largest raceway in a row. It says the distance shall be increased for additional entries by the amount of the sum of the diameters of all the other raceway entries in the same row on the same wall of the box. It says each row shall be calculated individually, and a single row that provides the maximum distance shall be used. Okay, just bear with me now. Again, 8 out of 10 people get this question wrong, even that simple box sizing. Okay. We don't need to worry about the exception, but the exception generally deals with when you have a raceway cable entry that comes in from the back of the box and it has a removable cover. If that's the case, the depth of that box is governed by table 312.6a for a 1-wire termination. Okay, so if you wondered why a box is 24 inches long, but it only has to be 6 inches deep, that's because you use table 312.6a based on the opposite of the removable cover from where the actual cable or raceway enters from the back. That's why the box only has to be so deep. Another question that people ask, again, I'm throwing you a lot of info, okay? A lot of info tonight. You also have to remember that the box only theoretically needs to be deep enough to facilitate the connectors, the lock nuts, and all that kind of stuff. That's the depth is all that's required. Unless, of course, it comes in from the back, opposite a removable cover, and then that's where the exception is going to kick in. But in our calculation, that's not the case. We have raceways coming in from the left, from the right, and from the bottom. So we don't have any coming in from the back, okay? It's not complicated. Just remember that exception for that rule. All right, now, make sure it's still on the screen. Yeah, okay. So this is the one we're saying, okay, so with the distance between raceway entries enclosing the same conductor shall not be less than 6 times the metric designator or trade size of the largest raceway. Now, this one can only be beneficial to you if they show you which raceways share the conductors, right? And so that could be on the exam. It could show the routing of conductors, and it might ask you the dimensions. The key thing about this one really doesn't play a role in the dimension of the box unless you can't get enough distance, okay, between raceways at 6 times, let's say it's trade size 3. So it's 18 inches. If you're unable to get the raceway entries far enough apart to go 18 inches, it might impact the size of your box. So those are the things. So you have to think about where you route these entries so that you can maintain that distance if they share what's called a mutual conductor. What's a mutual conductor? If a conductor comes in through a raceway on the left and then turns and goes through a raceway going down with no splice, those are mutual raceways that share the same conductor. Those have to be a certain distance apart. Pretty simple, right? So just think about those things. Now, in an exam question that gives you none of that, then you have an easier time of answering the question. So we know straights and eights. Okay, straight is 8. Angles with an S, plural, is 6. Okay, so let's go back to the question. Hopefully my everything's working okay tonight. And I'll catch up on some questions here in a minute. So let me make sure I've got everybody here. And I usually go so fast that I'm going to try to restrain myself and go a little slower so that I can answer your questions. I'm not in a hurry. So let's kind of look at what we're doing here. All right, so let's get started. First, let's work the first dimension. Let's work, let me get the right one on the screen real quick. Oh, before that, let me see if I can't answer a question before we dig into this. What is, because I want to show y'all this one. Let's see here. What does Elwood say? What if you bring in a bunch of 12s through the 2-inch distance between okay, so the difference is those conductors are not 4-gauge and larger. Okay, so they play no role in the dimension. You're still going to have the box fill, and all those 2 gauges have a cubic inch value. You with me? So you're still going to have to do that calculation. You don't worry about the box fill, the box dimension requirement or pull box is when you're dealing in 4-gauge and larger insulated conductors. So easiest thing to remember that, smaller boxes or device boxes, things like that. If you're dealing with 6-gauge, 8-gauge, 12-gauge, 10-gauge, and 14 gauge, you're going to have a cubic inch value. And you're dealing with 4-gauge and larger insulated, the question on the exam is going to be trying to determine dimensions. Okay. Now, look at hold on, let me make sure I answer all your questions, because again, that's what you're here for. Mandingo says, I'm sorry, this question is poor. Why wouldn't you know which way? Okay, see, Mandingo, that's the problem. Is that I had so many educators in an article that I did jump on me. People are not thinking exam. People have to stop thinking about the real world. Like you said, 12 conductors in there, Elwood. Stop. Just stop. Answer the question that's in the exam. Could I not have conductors go from the three trade size 3 on the left and go across to the 3 on the right? Yep. Is that plausible? Absolutely. Could I have conductors from the 3 turn and go down to the 2? Is that plausible? Yeah. Could I have conductors from the 2 on the left go up and go through the trade size 3 on the right? Is that plausible? Yeah. Could I have conductors that go from the bottom, number 2, trade size 2, and go up and turn left or turn right? All these are plausible. So we only want to answer the dimensions that are asked, and that is X and Y, and you always want to solve it to the most plausible answer, okay? So watch how this goes. Okay, let's solve first. All right, I got my little drawing here that I can do with everybody. Let's solve for the X dimensions first. Okay, so what's the easiest one? So X is what? Left to right, okay? That's what you see on the screen, left to right, or should I say west to east or east to west? Okay, so let's solve that one first. So the first one is straight as 8. So we always want to take the largest raceway. So some people say, well, can't I just go from the 2 to the right? Now, the largest raceway is trade size 3, and it's going from left to right, right? So we want to use the largest raceway times 8. So it's 3 times 8, right? So let's just kind of work this out first. And you go 3 times 8 equals 24, right? So 3 times 8 is 24, straight as 8. So first thing you're going to write down is you're thinking, okay, the straight dimension from left to right is at least 24 inches, at least right now. Right now. Okay, so I'm going to write that. X equals 24. But we're not done yet. Okay, so we got 24 for that. Now, we have to look at it and say, all right, what are we doing next for the angle pulls? Okay, let's leave the straight first because there's only really one straight pull in here, right? You with me? There's only one. Okay, so and that's the left to right, and that's the 3 to the 3 or the 2 to the 3, however you want to route it. Okay, that's the only plausible straight. Anything that comes from the bottom has got to turn left or turn right. Okay, all right, so we solved, so X is 24. Now we need to think about the Y dimension. So in the Y dimension, we have going from what? We have it going from south to north or from north to south. Okay, so we're thinking about that dimension. All right, so let's do it first. So the first thing we want to do, and I always tell people to do this, go around your walls. Do the walls first, okay? Always go around and do your walls first. Let's do our first dimension. You got your pen handy? So the first thing that we want to do is let's do some angle pulls. So we have 3, trade size 3. Let's start right here on the left side. Oh, sorry. Let me make sure I got my screen here. Okay, let's start on this left side, okay? So we're doing this dimension here, okay? All right, so, and we've got to do 2 things here, folks. We had the X going this way for the straight, but since we have angle pulls coming this way, we still have an X, so we don't want to solve for Y yet. We still got another X, and the X was what? It was the largest raceway on one side because we do have angle pulls. Remember, it said the largest raceway to the opposite wall. So we did the straight, that was 24, but now we need to see if that's going to hold up, if that's good enough. So now we have to do an angle pull. So that is 3, that's the largest raceway on this left side. So it would be 3 times 6, remember angles is 6. So it's 3 times 6, and remember what it said, plus the sum of the other raceway in the same row. Notice these are in the same row. So it's 3 times 6 plus 2. And that equals 20. So we already know that this dimension here, the straight times 8 is the greater dimension. So we're going to use that one. Okay? That one's done. You with me? All right. So all we wanted to do was solve for X. And we're doing this wall. Okay? Now, we don't need to do this wall because there's already a 3 over here, right? So since it's 6 times 3 plus 2 over here, since we're doing this wall, we would look this way, then it's only 6 times 3. So that's going to be less than what we did on this side. So we always want to use the greater value, okay? So we're using the left side over here now. Okay, so we've solved the X dimension, and it looks like 24 is it. Now let's solve the Y. Okay, so in the Y dimension, we want to do a Y dimension has only one option here. There is no straight through. There's only one option in the Y dimension. That's it. One option is all. Okay, so this way, I have nothing coming in up here, nothing here. I have no straight pull, nothing. So I only have one option. So what is it? It is trade size 2. So now we're going to go to this wall. We already did this wall. We're going to go to this wall. So that's a trade size 2. So that's 2 times 6. And there's no other raceways on this wall. So it would be 0, right? So that would be 12 inches. Okay. So the X dimension is 24. And the Y dimension is 12. So it is 24X, 12Y. Okay. Now I want an opportunity to answer any questions. Now, Felix, I'm not sure where you're adding the 20 because that doesn't go on the Y dimension. That did go on the X dimension, so I'm assuming there's a little bit of a lag in here, so that that's where you were probably at. Okay, so real quickly, the moral of this one for you folks is that you want to work this box all the way around. solve all the plausible x values first. Remember what it said in 314.28a? It said, do the straight one, it's 8, straight is 8. So I take the largest raceway times 8, and that was 24. Now, I'm on the left side wall. Don't I have an angle pull? Absolutely. And the angle pull says you got to go 6 times the largest raceway plus the sum of the other raceways that are in the same row. So that's why we started on the left, because obviously we knew there's 2 raceways over there. So that's going to generate the largest size, okay, the size that we have to have. So again, we did the, in order to get the maximum x, we did 6 times 3 times 6 plus the 2. And that's how we got the 24. With the y dimension, we only have one raceway to contend with, and that is the 2 on the bottom. So it was 6 times 2 is 12. Okay. So now Sir Fancy Pants says, I got how you got the 20. Where did you get the 4? I don't know where you're talking about for 4. I said 24. Not sure where that is. Remember, I have to do what? I have to compare the 2. I have to do one for the straight. Oh, hold on for a second. I have to do one for the straight, which is the largest raceway times 8. And that's the one thing to consider for the 8, for the x. And that was 8 times 3 is 24. And then since I have angle pulls on this side, which also are going to equate to the x factor, and I have to take the larger of the 2, the angle pulls in the code, hopefully you got your code book and read it. It says take the largest raceway. Remember it says sizing to the opposite wall. So you take the largest raceway, 6 times the largest raceway, plus the sum of the other raceways on that same wall. Okay? And that's how we got that value. You with me? But I don't know anything about 4. I don't remember saying anything about 4. Maybe the audio is not coming across well, but it's actually 24. So in this case, the x dimension, the straight times 8 was the greater dimension, okay, than the angle using the angle dimension. Okay, so again, so that's a common question. And here, look, if you get an exam, it really is that simple. Just go around the box. Remember that I have to solve for all the possible x's. That would be the straight, if there's a plausible straight. If there's a plausible angle, I have to solve that as well, because what did the code say? For angle pulls, it's from the entry to the opposite wall. That's why we had to do the straight one and we had to do the angle one for that x and see which one resulted in the bigger box. Always remember that. I think a lot of students just use the straight. In some cases, the straight wouldn't be the greater value. You might have a trade size 3, a trade size 2, a trade size 2. And so, again, if that's the case, then it would be 6 times 3 plus 2 plus 2. And that might result in a bigger box, at least for the x dimension anyway. You with me? Okay. All right. And then some people say, why didn't I do the right side? Because all I'm doing is sizing the x dimension. Obviously, the 3 and the 2 is going to be larger than the just 3 by itself. So there's no sense in me even doing the right side. So just remember, even though I didn't have conductors given to me in this question, I was still able to size the box based on the question that was given to me. And that's what you have to remember about exam. It's don't put the real world into it. Okay? Don't think about what will happen in the real world. They're always going to show me conductors. No, not on an exam. They do not always show you conductors. I know, because I've written some questions for exams that do not show conductors. So I know. Now, do I know if they used my question? I don't know about that, but I do know that I did do it. So anyway, there's that question. Hopefully you get something out of that one. Let me see if there's another one that we want to do on that page. Hold on. I've got a list of stuff written down here. So I want to go down to, let's see here. Okay, let's do number, let's see here. Let's do number 11, because I get quite a few people that ask me about number 11. So, so we're going to do, I have no graphics for that, Felix, so I can't really get into that. I'm going to talk about those conduit bodies in my November 21st. But to be honest with you, you still have the same dimensions, the same rules still apply with the conduit body, like an LB, things like that. Same rules. The thing about an LB is you got to remember that you do have a removable cover. So that's why the dimension coming in from one side can be shorter on one end, but then it's end up being longer because, again, it still has to meet those dimensions. That's why you have service L's or service pulling L's that are so large, because they have to meet the size of the raceway in order to get to the opposite wall. Okay, so something like 6 times the raceway size, and so that dictates your LBs and things like that. So there are some special rules for that, but we're going to cover that in my my class on that. I really want to stick to my fast track program tonight. If I go off lib, then I'm going to have to come up with boxes and graphics that I just don't have available for me to do that. Again, I do the best I can, but I can't tailor it to that type of thing. If you have a code question, I can answer it, but this would require me to show you a box and an LB, and I don't have one geared up. All right, so number 11. What is the? Oh, I should mention, any of you do have questions, you can always email them to me, and as I got time, I'll answer your questions. Okay, to do that. So number 11 says, what is the maximum number of 12 AWG THW conductors permitted in a 4-inch Octagon box that is 1.5 inches deep? The box contains a fixture stud and a hickey. Okay, I see some answers coming in, but I'm gonna get you to think about that for a second. So what is the maximum number of 12 THW conductors permitted in a 4-inch Octagon box that is 1.5 inches deep? Okay, so let's do this. Let's do this together. So at least somebody. Okay, I've got a bunch of different answers. I don't have the right answer yet, so keep working at it. Keep working at it. So we have to come up with. First of all, it's a 4-inch, and I'm just jotting it down because I got really, really poor memory these days as I get older. And it's a 1.5 inch deep, and it's an Octagon box. Okay, so where am I going to go in the code? I see some references that were made earlier, and I think that those, now everybody's giving me some numbers here, but this is good. We're going to work these things out. And Jeff is almost unfair because Jeff just finished this program, but I would expect as much from a fast tracks student. So very good, Jeff. I would expect him to pop that answer in just like that. All right. So at this case, let's kind of go. So what's the first thing we noticed? We need to first look and see what the so we know they're 12 gauges. Okay, we got it. So first thing we're going to do is we're going to whip into the code if I got it geared up. And we're going to look at it because I got all different kinds of answers here. Okay, we're not using the 2014 NEC, sorry, 2020 NEC. But if it works for you, that'll work. So I'm going to go to, let me just go to the top real quick. Okay, it's 314. Here we go. Okay, so first things that I like to do is, okay, so B4 devices and all this kind of, we got all this kind of good stuff. But let's so we're here where we need to be. Okay, first off. So we got to go, let's go back to the question. Again, we're taking our time. We're learning how to code because I got a lot of people that got the question wrong. So we're going to go back just enough to get back to the question. Okay, now it says, what is the maximum number of 12 AWG THW conductors permitted in a 4-inch Octagon box that is 1.5 inches deep? The box contains a fixture stud and a hickey. Okay. So y'all probably learned by now, we're going to have to go to a table. Okay. The good news is right here, it all tells you This is, the amount of the volume or whatnot. But we're going to go to, and again, bear with me while I get this thing won't work right. Okay. So it was a 4-inch by 1.5 octagon, right? So let's see if it's 4-inch by 1.5 octagon. And how many did it say that we had? It said 6 12s, right? So interesting. Let me teach you a little bit of something about this table real quick before we go on. And you can't see the whole table, so let me adjust it down a little bit. There you go. Okay. So the interesting thing about this table is you notice that when it says maximum number of conductors, so these are just metal boxes. This is metal boxes. If it's not non-metallic boxes, just metal boxes. And this question, it didn't say it was metal or not. Okay, so again, we're utilizing for this. It didn't really say that it was a metal box. Okay, but when you says it's an octagon box, then it's a 4-inch one, and then that's pretty much, if you're in the trade, that sounds very much like a metal octagon box. Okay, we're just going to use some leeway there. Again, your question could be different on an exam. But anyway, it says 12 gauge. So if all of the conductors are the same that come into the box, and everything is being equal, then you can have up to, hold on here. Oh, wait a minute. I don't want my thing to time out. There we go. Sorry about that. All right. You can have up to 6 12 gauges in that box. Now, interesting enough, when we say a device is a double volume, basically think about that as being 2 12s. If it was 12 gauge conductors going to it, so it's 2 12s. If you think of a hickey, it requires 1 conductor. If you think it equates to 1 conductor, it takes up that. If you think of a what else? A device, again, I told you that takes up 2. So even though you've got numbers here of the maximum number, they might equate to a device or a hickey or something like that. We just need a number to start with. So I can have 6 12s in that box, right? You with me? All right, so in this case, I can have 6 12s in there. So now we go down, and remember what it said we had in the box? We had studs and hickeys. It says where 1 or more studs or hickeys are present in the box, a single volume allowance in accordance with table 314.16b shall be made for each type of fitting based on the largest conductor present in the box. Well, it's 12 gauges, okay? So I have 1 hickey and I have 1 stud. So each of them are a single volume count. So remember, we started with 6, right? That's what it said right here for the octagon box. It says 6 right here. We started with 6. That's 6 conductors. But it also could be 6 12 gauges that are a volume count. So it's a 6 volume count if you kind of follow with me. So the hickey says that I got to have 1 for the stud and 1 for the hickey. A single volume allowance. And you see the or in here? Since we got both, it's 1 for either. Okay? So in this case, let me go back to the code question. And now you're going to have that moment where you go, oh, I get it. Right? You'll say, oh, I get it now. Is you basically take the 6 minus the 1 for the hickey and 1 for the fixture stud. So that's 6. Remember that 1 volume? 6 minus 1 is 5, minus the other one is 4. So what's the maximum number of 12s that can be put in that box? 4. Okay. I had a lot of you throw up their 6 and 5, and nobody said 4. So just make sure you remember that devices like switches are a 2 volume count, basically 2 conductors of the size that's connected to it, if you will. Let's see. That is probably very common on a question, on an exam, simply try to make you think how many conductors you have after. And a lot of the questions on the exam won't be fixture studs and hickeys. I think that Last time I've actually seen fixture studs and hickeys was back when I was an apprentice, and that is, well, I'm not that old, so I'm not going to say that. I'm sure Elwood will say it, or somebody, but I am not that old. My Grecian formula didn't work this morning though. But anyway, this is a good question, a good basic question that makes you think, and that's what you're going to get on the exam. Stop and think, that type of thing. All right, let me see what other questions that I have written. Let me go back real quick, guys. I got a couple more here that I want to do. Let's go. And this is a Fast Tracks program for those that are familiar with it. Let's go to, let's see, I don't want to go there. Very common question. Let's go to here. Now let's go to question number 11. Okay, let me make sure that's on the screen so you can see it. Okay, so y'all see 11 here. Another question, believe it or not, that people, get some paper here so I can work this out with you. Another question that people seem to be having now, people watch my videos all the time on the ranges and something like, but for some reason, people have to, get range calculations wrong. So we're going to work one out. Now, before I do that, O has a question. And again, if anybody over in the Facebook stream has a question, just type it. I haven't checked it, but I will check it. Let's see here, O. Let's see if I can answer your question. It says, so that round box won't have a fixture, but a evocar such as a duplex receptacle. Typically, round boxes wouldn't have a receptacle in it, but if you did, and that Octagon box had a receptacle in it, then it would be equivalent to a 2-volume count. So it would be equivalent to 2 conductors. So it was 6, take away 2, and it'd still be 4. Okay? And remember, this is only when all the conductors in the box are the same size. And it makes it fairly easy. Oh, I should mention, in the real world, plastic boxes, nail-up boxes, all that kind of stuff. Inside the box, it will tell you how many 14s you can put in there, how many 12s you can put in there, how many. And so if you ever see the numbers in the back that are embossed in it, it says 812 or 612 or 910 or whatever the numbers are. That's literally how many conductors. Now, you think, well, wait a minute, does that mean conductors and devices? No. Remember, a device equals 2 conductors. Okay? Remember that, okay, per strap. So, I mean, it's 2 conductors. And so, again, when it starts taking up volume, that's where you got to think about the question on what kind of devices actually take up the volume in something. So just keep that in mind, okay? Let's see here. Okay, Bill's already worked out the question. I'm going to say no, Bill. But try again. Keep it. Now let's read this question. There's a key thing in this question that throws people. Okay, let's read it. It says 1 cooktop and 2 ovens are connected to 1 branch circuit in a kitchen of a 1-family dwelling. The cooktop has a nameplate rating of 4 kW at 240. While each oven has a nameplate rating of 5.5 at 240 volts. So it says the minimum load calculation for this branch circuit is blank watts. Now, one of the beautiful things about Note 4 in 220.55 is the ability to use the information from 220.55 in order to size the circuit for the branch circuit. So it gives you that ability to do that and work that out. So I'll have the code keyed up. So first thing we want to do is let's go read the note so we understand it. So if you get an exam question and your exam question says that you're sizing the branch circuit, remember Note 4. If we're talking about for ranges and I mean for cooktops and ovens, remember Note 4. If it's asking you for a load calculation or a feeder calculation, then it's going to be Note 1, 2, or 3. You with me? Okay. Close, Bill? Not there yet. Keep plugging away. Don't give up. Don't give up. All right, so let's go to the code real quick and make sure that we wrap our head around the code reference first, and then we can come back and solve this nifty little question here. All right, so let's go to the code. All right, so in the code, you know, Jeff is my superstar lately. I had many superstars during my series of students through the years. You know, Jay and Tim and a bunch of other people. But, you know, Jeff has emerged as a top notch in the latest edition of the Fast Tracks program. So good job. Good job, Jeff. All right. So, and hopefully you're going to keep me updated on your exam if you passed it or whatnot. I'm hoping you got everything crossed. I don't know. You might have already taken it. I don't know. All right. So let's look at ranges really quickly. And again, I want to make sure that I'm not blocking anything out here real quick, so bear with me. Okay, see note 4 on the screen. Now, of course, if you can't see note 4, we're at 220.55 under the table. Crack your code book open. I hope you got your code book with you. And I'm going to read it. And so we know how to apply it here. And then we know what we had. We know what we had is 2 5.5 kW ovens and 1 4 kW cooktop. We know that. So let's read this. It says, number 4, it says, branch circuit load. It says it right out the back. If you have a highlighter and you're in a state that allows you to highlight, one of the things that I would highlight would be that first couple three words, branch circuit load. Highlight it. And don't highlight anything else. You know I'm a big believer in not going highlight crazy, folks. You know that, right? So, all right, so let's read item number 4. And you got your code books. Follow along with me. It says, it shall be permissible. Okay, so it's a permissive statement. Means you don't have to follow this rule. You could take it at the full value and size circuits for nameplate ratings and just be happy. But why would you do that? So it says, it shall be permissible to calculate the branch circuit load for one range in accordance with table 220.55. So I have one range. I'm doing branch circuit sizing. If it's run one range, 8 kW is all it has to be. It could be a 10 kW nameplate, but it only has to be 8 for my calculation because it says that I can use table 220.55. But that's not going to answer our question. We got to go further. Okay. The next part of this question says the branch circuit load for one wall-mounted oven or one counter-mounted cooking unit shall be the nameplate rating of the appliance. Okay. So if it's just one wall-mounted oven unit, you take the nameplate. Or one counter-mounted cooking unit, you take the nameplate of that appliance, okay? It's giving you direction here. It says, the branch circuit load for a counter-mounted cooking unit and not more than 2 wall-mounted ovens, which again applies to our question. Remember, it's 1 cooktop unit and 2 wall ovens. So this part does apply to us. It says, all supplied from a single branch circuit, and of course, our question is talking about a branch circuit, of course, and located in the same room. This is an exam question, so you don't have to speculate. I get people all the time to say, well, how do I know it's in the same room? You don't care. You know what they're trying to ask you. Don't let the mind wander on an exam. We know you have the skills. I know you have the hands-on training. Okay, you wouldn't have been permitted to study for an exam if you didn't have that time in. Don't overthink these things, okay? Now, it says, shall be calculated by adding the nameplate ratings of the individual appliances and treating this total as equivalent to one range. So what we're trying to do is come up with the range and then we apply the rules. So what are we going to do? All right, we've got the rules and I will go back here. So if we need to come back here, we will. But I'm going to go back to the reading material so we can kind of work this out. Work it out with me, okay? Oh, no, it doesn't, Bill. You're killing me. You're killing me, Bill. All right, let's work this out. Okay, so we said take the values here. So it was a 4 kW, so I'm going to write 4 kW down. You write it too. The next is 2 5.5. So go 4 plus 5.5 plus 5.5. Okay, add it all up. What do you get? All right, well, let me get my trusty calculator as well, just like you. And you know my tip for calculators, folks. Don't go into an exam with just a solar one, and don't go into an exam with just one with a battery. Okay? Because you've probably been studying, so the battery could be bad, go bad while you're in the middle of it. Or you might be in a test center that's got really crappy light and solar not working. That would suck. That's my product tip for the day. All right, so 4 plus 5.5 plus 5.5. That is 15. You with me? So I'm going to write that down. So that's 15 kW. Okay. Now, what do we got? Remember it said add it up and treat it as one range? Now, what I've got is a 15 kW range. So now what do? I have to apply the notes, right? I use note 4 to get me there. Once it becomes a single range, then I get to apply what? Remember what the first rule said in the first sentence? It says I get to use table 220.55 for sizing my range. My cooking appliance, that's what I'm going to do. So that's what we're going to do. So now let's go back to the code and do it. We know we got 15.15 kW. Okay, that's where we're at right now. So let's go back to the NEC. And again, I take my time on these because these are ones that you really want to nail on an exam. Okay. All right, let's go down to the note. Okay, so what note is going to apply here for us? Okay, well, note number 1 says it's 12 kW, over 12 kW through 27 kW ranges, all the same rating. Okay, it is. It says for ranges individually rated more than 12 kW, and our new range is, okay, it's 15 kW, okay, but not more than 27. The maximum demand in column C shall be increased 5% for each additional kilowatt or rating or major fraction thereof by which the rating of individual ranges exceeds 12 kW. Okay, so what's the first thing we want to do? How many kW do we exceed 12? Because that's what it says at the very end. We're only going to apply this 5% for each kW that exceeds 12. So we take that 15, right? I'm making my notes too, just like you. I take the 15 minus the 12. What does that give me? That gives me 3, right? So I exceed 12 by 3. Now it says 5% for every kilowatt that exceeds 12. What did we exceed it by? 3. Okay, so what we're going to do is we're going to do 3 times 5%, and that's going to equal 15%, okay? Now, remember here's where people get mixed up. Didn't we say we can treat it as a single range, right? So you go back up here, and we're going to treat it as a single range, and as you see right here, column C increased by 5% for each additional kilowatt or major fraction that exceeds individuals. So in this case right here, we're going to do 8 because it's a single range. And it's 8 kW. Okay. So we're going to do 8 times 15%. And that's going to be 1.2. So you take your 8, right? You take your 8 and you do what? You add the 1.2 to it. So it's 8 plus 1.2. And that gives you 9.2 kW. Okay? So let's go. Now, you're thinking to yourself, is that the answer? 9.2. And you go write that down real quick on an exam. You go, okay, it's 9.2. Now we have to look at what the question asks, because you might put 9.2 kW and you think you got it right. Now, a lot of students do this. Now, till we know our answer, let's go back to the code. Let's see. Hopefully it went back. It went to the thing. Okay. What did it ask me the question? It wanted the answer. Now, this happens all the time. It wants, you put on my exam or my competency, you put 9.2 kW, and I sometimes mark the students' answers wrong. Why? Anybody know why I might mark it wrong on question 11? Why do you think I might mark 9.2 kW wrong? What do you think, folks? Well, one reason I would mark it wrong is because it's asking for the question in watts, right? It wanted to know what the watts were. So 9.2 watts isn't going to work. It's 9,200 watts. That's what's going to work. Okay? Makes sense? The other question that people ask me with this question is they go, well, wait a minute. You said it was 15 kW, but column C says not to exceed 12. Okay, that's individual units. We combine them together and treat it as one, and then we're able to apply the note. And that's where we get the 5% for every one that exceeds 12. Okay? So that's your base, and then you apply it to that. So hopefully everybody got that question. Didn't find that was too awful difficult, I guess. Not real difficult. All right, so here another question that I like to throw out that people get wrong is question number 3, believe it or not. Here. Number 3. I'm not sure why this is routinely wrong, but it is, and it's because it says, okay, a 15 ampere rated duplex receptacle may be installed on a blank branch circuit. Okay, so what is it? A 15 amp, B, a 20 ampere, C, 15 or 20 ampere, or D, a 15, 20, or 25 amperes. Wow. That would be this. That would be. But I don't know. What do you think? Give me the code reference. How about that? Let's do one, because then I'll get into another calculation here in a little bit. But give me this. What do you think? So I've got a 15 amp duplex. Okay. Elwood says A. O says A. Now, y'all is guessing, or are you actually looking it up? Because again, I find that exam prep, you only create an issue in your memory by guessing. We want to make sure you pull the code book out and look it up and see what it could be. All right, now for me, it's talking about a branch circuit. So if I was, hopefully all of you watched my root dissection video. No overcurrent protection. Felix, don't overthink this thing. Okay? Don't overthink it. Just answer the question. Don't overthink it. Just answer the question. This isn't real world. This isn't life. This is answer the question. Although this one is. So you have a 15 amp rated duplex receptacle, and it may be installed on a branch circuit. We're not talking about the overcurrent protection, but be honest with you, the overcurrent protected device has to protect the branch circuit anyway. Okay, so it's kind of work together anyway. So you have 15, 20, 15 or 20, and obviously D makes no sense. So if you're in an exam, you can already increase your odds by getting rid of D. D doesn't make sense. Okay, so where do we got to go first? Well, the first thing we need to go to is realize that we're dealing with what? We're asking ourselves about a receptacle rating, and it's in a branch circuit. So we know that 210 deals with that. Okay. So you could go to the index and look up receptacles, look under branch circuits and probably see receptacles and utilize it that way. So we know, and I've seen a lot of people give me references now, but when they did it, now some of the correct answers are starting to come in now. So that's good, because I was a little worried there at the beginning. So let's go look it up in 210. And now the reason I'll show you why this gets this wrong, so I'll use it as a little lesson while we're there. Okay, so let's go to the NEC. While we're here, I'll go back up to the top here for this calculation. Okay, so we're going to go down to 210.23, or excuse me, 21. I don't know why I said 23. Right here. I don't know if y'all can see it. All right. So 210.21 receptacles. All right. So we have what's called receptacle rating. So when I look at the question, right, the question has to answer me, it's asking me what? I need to know what is the maximum branch circuit that I can supply this 15 amps duplex receptacle. I mean, that's what it's asking me. I know it's a 15 amp duplex receptacle, right? I already got that. So it seems like I'm trying to find out what's the rating of the receptacle, which is 15 amps. And so two places that we could look, and we can get that answer from both places anyway. But this is talking about cord and plug and the maximum load that can connect it on it. This is where we want to be. So, for example, here's the receptacle's rating. Remember we said it's a 15 amp? So, not over 15, 15 or 20. Okay. Oops. 15 or 20. We seem to be okay with that. Okay. Now, up here, you'll notice that one of the places that we look at is it says the circuit rating, 15 or 20, can have a receptacle rating of 15 amperes. Okay. So we've got there is our answer. A 15 by itself. Here it's trying to say receptacle ratings various circuits cannot be over that. But we have to remember what it says here. We're connected to a branch circuit supplying two or more receptacles, and a duplex is, by the way. Receptacle rating shall conform to the values listed in table 210.21b3, or which ratings higher than 50 amperes, receptacle rating shall be not less than the branch circuit rating. So if it's higher than 50, then it's got to be whatever the rating is. Okay, whatever the rating is. So in this one, the answer is dealing more accurately. It's going to be allowed to be a 15 or 20. Okay. So let's see where we go back here. And I am lost on my pages here, guys. Hold on. Sorry about that. So we're talking about the receptacle. Okay. I think I'm back at it. We're talking about the receptacle, and we're trying to determine the branch circuit size. Okay. So if we find the receptacle, then we know what? We know what? 15 amp receptacle? 15 amp receptacle can be on a 20. 15 amp receptacle can be on a 15. So both 15 and 20 are applicable, right? Not a problem, okay, when it comes to the branch circuits. This is the receptacle rating. It said a 15 amp rating receptacle. So 15 right here, it's perfectly fine for 20. And then, of course, it should be no brainer that a 15 amp rated circuit is okay for a 15 amp receptacle. For some reason, people seem to miss this and only put 15 because they don't see this thing. And they do the same thing for this one too, 40 or 50. So if I have a 40 amp circuit, I can have a device rated 40 amps or 50 amps on it. If I have a 20 amp receptacle, I can have a 15 or 20 amp. And now you're going to ask yourself, it's going to be painfully clear when I say this. It is very common to see receptacles in the kitchen serving your countertops that are on a 20 amp branch circuit, right? To be really 15 amp rated devices. It's very common, okay? And another little tidbit for you. The internal guts of a 15 amp and 20 amp duplex receptacle are exactly the same. They're exactly the same. The only difference is the faceplate and the configuration of the slots. 15 is straight up and down. And then, of course, you've got the 20 amp one, which is one straight and one's kind of a T. That's the only difference. Internally, exactly the same. I learned that when I was with NEMA. They're exactly the same. Do they charge you more for the 20 amp device? Absolutely. Even though they're taking some of that plastic off and giving you a little T slot, they still are going to charge you more for the 20. I'm just saying. Now, that's not the same for commercial grade, because the commercial grades are a little more robust. So those do change a little bit when you get a little bit bigger. But a commercial grade 15 and a commercial grade 20, they're exactly the same. And if they tell you otherwise, go out and get your own and test it, and you'll see that. Okay. What does Elwood say? What about disposal switch toggle 20 amp device on a 12? Not sure the question. If it's a cord and plug connection, for example, and you look up there, you see the maximum. I don't know if you can see that in the screen. I guess you can. The maximum cord and plug. If it's a cord and plug disposal, then you're going to have a limited of the load that can be on it. The maximum load that can be on a cord plug connected receptacle, 20 amp receptacles, will be 16 amperes. Because it's cord and plug, it's going to be limited because of the cord and plug connected loads to a receptacle. Okay, that type of thing. Yeah, so that rule is a little different. That's the rule that follows, and again, that is under permissibles, and that one is going to be more down here where you talk about the 80%. So here's a cord and plug equipment not fastened in place. The difference between these, this is just plain cord and plug connected application. So this even applies, believe it or not, to all receptacles that would have cord and plug connections to them. We don't really, be honest with you, and just know how to do it in the code, but we don't take those considerations. But all those receptacles that run around your wall, theoretically, they're 15 amps, but you're not to exceed 12 amps on them for maximum cord and plug connected loads for receptacles. But I don't think anybody cares about that because, to be honest with you, nobody would put that much load in it. But again, it's just kind of something to know about. Now, when you're down here and what you're talking about is under 210.23, and that's an example where you have cord and plug connected equipment that is not fastened in place. So this is specifically, so this one here, folks, is for anything that would plug into a receptacle. Down here, it's more or less dealing with the equipment that is cord and plug connected that is not fastened in place. I will tell you this, a garbage disposal is fastened in place. So that one's going to fall under this one. So that's not going to be one that, but if you had another piece of equipment, then then you would be limited for cord and plug to not fasten in place, not exceeding 80% of the branch circuit. So whatever the branch circuit is, you can't exceed 80% of it for a cord and plug connected equipment not fastened in place. Dishwashers, I consider fastened in place. Garbage disposals, I consider fastened in place. Those type of things. So just understand these rules for that, and you won't see this nearly as much about the cord limitation for receptacles. But as Tim said, you will see them ask you about a receptacle device rating and what are the circuits that can be connected to it. And you might get a question or two about utility equipment fastened in place, which would be 50%. Okay. Now here's what this one says. And I didn't want to get off of it because when I get off on these tangents, it's sometimes hard for people to follow. So that's why I'm using questions so that we can really analyze the questions. But I'll go on and talk about it while I'm here. It says the total rating of the utilization equipment that's fastened in place, whatever that piece of equipment may be, okay, other than luminaires, okay, so other than luminaires, it says shall not exceed 50% of the branch circuit rating where lighting units, cord and plug connected utilization equipment not fastened in place or both are also supplied. Okay, so this one really only comes into place. So where would this come into place? So let's say I had a circuit and I've got a dishwasher and I got a garbage disposal. And people ask me, people always want to put them on the same circuits. Well, you're going to have a problem with that circuit because it can't, the actual load, okay, the total rating of whatever the utilization equipment is that's fastened in place cannot exceed 50% of the branch circuit's rating. So if it's a 20 amp branch circuit, it can't exceed 10 amps, where it has other cord and plug connect utilization equipment that are not fastened in place also being utilized or potentially utilized on that same circuit. This would not apply to my cord and plug receptacle that simply goes to a garbage disposal, okay? Because that's still fastened in place, okay? That wouldn't fall under the cord and plug equipment not fastened in place, okay? So just kind of some of those rules to be aware of. Let's see here. Moise says, Elwood, you're talking about toggle switch ratings. I'm not going into that tonight, Elwood. Are you talking about using it as a disconnect, or it's just a toggle switch? Its rating is within its rating. Okay, you use it within its rating. Let's see. Moise says, is a bathroom fan a fastened in place appliance to take in consideration in load calculations? That has nothing to do with this application here. If you're talking about for a load calculations, we did have a change in the 2020 code that it does not require you to take into consideration the bathroom fans. Why? Because I believe they're going to be less than an 1/8 horsepower or smaller. They're just really small loads, so you don't have to take them into consideration. And that was a change to make that very clear in the 2020 NEC. So yeah, you don't have to account for those bathroom fans, those fart fans, exhaust fans, or whatever. You don't have to take those into consideration. I will tell you, Elwood, about your switches. All you got to do is go to 404 and for switches, and it should tell you everything that you need to know about switches. Okay, and if you were using a switch as a disconnect, basically a snap switch, it's good for 15 amps. It's good for 15 amps. Depending on how you use it, could have some limitations on it, but usually nothing significant. In other words, if I'm already sizing my device for the receptacle for 20 amp and I'm taking all these considerations into it, then that's not going to play a real role on this switch. Now, for an exam, just remember that 404 will have rules for switches and things like that. And if you ever use a toggle switch or a snap switch for a disconnect, then you got to remember that you have disconnect rules in 430 for motors if you use it, because some small motors will let you use a toggle switch. Then you have limitations there. It might be 80% and all that, or sometimes you have to even have horsepower rating switches. Okay, I'm going to probably I cover that, I believe, in one of my motors videos, I think, when we talk about switches. If I got time, I'll circle around to that, but let's answer a couple more questions. Let's see here. Another one in the exam prep. Let me go back to the exam, to the program real quick. Another one in here. Oh, so the answer in this one obviously is answer C. Okay, so for those that wondered what that was. Another one that we look at is 6. All right, number 6. Give this one a shot. This one seems to, for some reason, give people a little bit of trouble. And I want to, talking real life. Yeah, but I wouldn't worry. In the realm of 210.23, for those circuits, I wouldn't worry about the snap switch. A 15 amp snap switch, since it's not actually having any load, and everything about 210.23 is dealing with loads. There's no real issue with the snap switch to worry about in that scenario. But yes, there is for motors. There is when you use it as a disconnect for a piece of equipment. There are things you have to take into consideration, but not for something that's pretty simple for like disposal and things like that. Obviously, the circuit's rated for it. So if it's a 20 amp circuit, snap switch is rated 20 amps. It's not gonna be a problem. All right, so look at number 6. And I wouldn't expect that on an exam. I wouldn't, but I never say never, but just be familiar with 404. So it says a one-family dwelling has a front entrance on the east side of the house. An attached garage has 2 10-foot wide doors on the south side. Okay, so we're thinking the garage doors. Okay, and it has a back entrance door on the west side of the house. It says the one-family dwelling requires blank lighting outlets for these outdoor entrances. Okay, so think of a dwelling, and I've got a garage. It's attached garage, and it's got 2 garage doors, 10-foot doors that kind of come up. Your car garage door for your car, and I've got an entry into the dwelling on the east side, and I got an entry into it on the west side. The question is, for a one-family dwelling, it requires how many lighting outlets for these outdoor entrances? So what's your answer? Okay, what do you think? I have 2 garage doors and 2 doors to the dwelling. Give me a code reference, and where would you find this? And while I'm looking over here to see if we've got any questions on the Facebook stream, I do not have likes over there. Appreciate the likes. Thank you, everybody. Again, anybody that's following over on the Facebook, there is always a chance that you are chatting and I can't see it because I don't support that usually. So I'm going to go check real quick while people are looking up these answers here and see if I answer any of y'all's questions too, because I know if y'all have questions too, I want to make sure that I answer them, but I'm not seeing any. Hold on, I'm not seeing it here. So there is a problem with the software. I apologize when it comes to you folks over on the Facebook, which is why I don't usually Facebook stream, by the way. So I apologize. But I'm looking to see what you've got here. All right, and I don't know if it's working or not because I have nobody that posted a question or posted, "Hey, Paul," or anything on there. So I don't really know if that's working or not. So if you're over on the YouTube, Facebook, say, "Hey, Paul, what's up?" And I'll see if it works. Maybe they fixed it. I don't know. But if you're not, come on over to the YouTube stream. That's where I do most of my stuff on the YouTube stream. All right. All right. So we do have some answers coming in. Javier. Okay. Name sounds familiar. 210.72. Okay. I see Jeff. Very good, Jeff. Let's see here. Now, Felix, you said 210.8, but 210.8 is GFCIs. So we're not asking about GFCIs. We're asking about lighting outlets. Tim, got to get with the times. Yes, you do, Tim. You already got your thing for the 2017. You should start learning the 2020 and reduce that curve. There you go. A lot of changes in the 2020. And funny, folks, I just get out of committee meetings today. We are already starting the 2023, believe it or not. We're already looking at all those public inputs, and there's a lot of them. Just when you think there's not enough stuff to change, we're changing more stuff. Okay, first thing we have to realize, and I got some answers here, so we're good to go. When I see this question, dwelling unit, remember that you're required to have a lighting outlet at each entrance to a dwelling. There's no requirement to have it at the entrance to garage doors, although it makes sense in the real world. So this is another example why people get this one wrong, and they go, okay, I have to have a lighting outlet at every entrance, so I consider those two garage doors because the question didn't say garage doors. Yeah, but again, it's an exam. There's a reason they're asking you this question. It says two 10-foot doors. They're not like normal doors. I have had students that want to argue this because they get it wrong, and they say, "Paul, you got to give me at least half credit." And I'm like, remember, my credit that I give you in the program means absolutely nothing. It's you passing the exam that means everything. So I want you to think about the question and say, isn't that garage doors? Now, we put lights at our garage doors, floodlights and all this stuff. The fact of the matter is, the code doesn't require that because those are not considered entrances to the dwelling. So we have really two entrances to the dwelling here. We have one at the back entrance and we have one at the front entrance. So for all of you that said two, you're absolutely right. It would not be at least one. Alan, thanks for coming. Alan, Alex, thank you. Also, Jesus, thank you for coming. Jeff, Xavier, okay, I want to make sure I mention out everybody. So the code requires that you have one at each entrance, at least one at each entrance. So I think that's probably what you meant, Alan, at least one at each entrance. I think that's probably what you meant. So let's kind of go to the code real quick so that you know where it is. Now, if you're studying and you're using the informative annex, maybe you've got some of our new P tabs, and you'll notice that you have index tabs now, A, B, C, D, E, F, G, all the way down to Z. Okay, so we include those in our P tabs. So if you haven't gotten those, order them. And incidentally, the J tabs will be out by, I think, the weekend, maybe the first of next week. J tabs are simply tabs of the most commonly used tables within the NEC, and it'll go across the top of your NEC. So it saves you time. All of the key tables and calculation tables that you need to have quick access to it. Okay, so we're coming up with those. They're called J tabs. Name them after Jay, who's my co-host with Electrician Live. And of course, P tabs are after me, Paul Tabs. Okay, so if you ever wonder what I mean by P tab. All right, so we have those available. Check them out. They're nothing fancy. They're nothing fancy, but they're nice little tabs, and I like them. All right, and they're exclusive from us, so check them out. And over on our website. All right, so let's work this out here. Let's go to the code really quickly on this one. So we're at 210 now. If you were doing this in the index, you would look under where? Where would you look under? So this is lighting. It's a lighting outlets. I might look under lighting outlets. I might look under dwelling units. I'm looking for key terms in here. Okay. Now I'm not going to go look this one up because it's pretty straightforward. But if you were doing that, and also since the 2020 electronic edition online doesn't have an index, I'm kind of crippled with that. I got my code book, but I can't share that with y'all. All right, so I'm going to go to the NEC. And in the NEC, when you think about this is all has to do with those branch circuit requirements, receptacle spacing, 210.52, boardroom, meeting room stuff, that's 210.65. You got all this other kind of stuff. You'll start to learn how 210 is structured. And if you're in my Fast Tracks program, you'll learn really quickly because, again, we really hammer a lot of the spacing rules and all this stuff in our Fast Tracks program. Again, if you want more information on the Fast Tracks, check out our website. Incidentally, we did have a price increase, but again, coupons flow around all the time. Or if you email me, I might be able to give you a hint on where you can get a coupon or something. All right, so let's kind of go down to 210. That's it. So we're dealing with, the question was about lighting outlets, right? Okay. So in this question, what's our key thing we're trying to solve for? We're trying to solve for how do we know how many lighting outlets that we need? All right, so these are down under additional locations because we have the locations for lighting outlets that are in habitable rooms, and that covers the rooms inside of your dwelling. Okay, but now we're talking about additional locations. Okay, well, let's go down to here, and you're going to see, let's see here. Yeah, I'm going to write this down. So we said that we had a front door and a back door, and we had 2 garage doors. Okay, all right, so let's read down here. Here's what it says. 210.70A2. What does number 2 say? It says for dwelling units, okay, that's what we've got. It says attached garages, okay, and detached garages with power doesn't come into play in what we're asking right here. It makes no difference. It says at least one lighting outlet controlled by a listed wall-mounted control device shall be installed to provide illumination on the exterior side of outdoor entrances or exits with grade level access. It says a vehicle door in a garage shall not be considered as an outdoor entrance or exit. Well, you can't get very much more straightforward than that, right? So if you looked at the exam question and you got here, then you kind of know what they're asking you. Okay, so it's not a big deal for that one again. So the answer is 2. And it looks like most of you came up with 2. Okay. And now Alan says, for those out there that are learning, he says, I went to the lighting and then looked for outlets. The index said reference lighting outlets. Then I found the section. Well, there you go. There you go. And that'll get you there. So many ways to do it. For all of you out there that may be new, that have never used it, the index, watch some of my other videos of Wednesday nights that we've done in the past, and really go back. Well, also true, but I think that garage doors are probably grade level as well, Tim, but a good point. Grade level can be the key. One of the things that I tell people all the time is watch that video that I do called Dissecting the Root of a Question. Please, if you do anything, make sure you watch that video. Because I spend a lot of time saying, look at a question, read it, dissect it, find the keywords, and then go to the index. you know what? I'll be honest with you. When you're studying for an exam, I want you to spend as much time as you can in that index, because you start learning things in the index. What you really learn is, I don't need to go to the index because something's not there. And you really start to learn what's not there. And trust me, it's been doing this for over 30 years. It just comes natural, and you'll get it. Trust me, you'll get really good. I mean, look at Tim. Okay, he's nailing it. Okay, and look at Jeff. Okay, so you can do all of that's just so easy to do. But once you get used to it, let's see if I can look here on my list and if I've got another good question that people have trouble with. Oh, yeah. So I got Unit 8, which Unit 8, if you ain't in Fast Track program and you ain't done Unit 8 yet, and you ain't had a problem with Unit 8, then something's wrong. Because Unit 8 gets everybody, okay? You're not alone. Now, Unit 8 has got some really good stuff in it, okay? So we'll probably want to calculate this out, and you want to work one out? Let's do one first. Let's do number 5. Let's do another one that's dealing with a calculation. All right. But this is a little different than the other one, because this one's dealing with the demand load for the service. The other was dealing with the branch circuit. Now we're trying to find a contribution to a service calculation. Still going to use 220.55, but it's just a different way to think about the question. I want to make sure you know how to answer this. Then we'll go to the one that I intended to go to anyway. But I want y'all to see if y'all can answer this one. Okay? So it says, let me make sure that it's still on the screen. No, it's not. So y'all can't even see what I'm looking at. So again, I apologize. I'm glad I caught that. Let me go back to the code book. Then you'll be able to see it. All right, right there on the screen. Let's answer number 5. Okay. Thank you, Jeff. I caught that, and I'm checking myself. I'm always trying to check myself. I get so much crap going on. All right. So look at number 5. Again, I just want to hammer home that you understand the difference. The other question about ranges was dealing with sizing the branch circuit. Okay. And the loads associated with this one. This one makes a mention about certain things, but it is all about the load calculation or the demand calculation for service. So I want to make sure that you fully understand this one before we go on to the one that I intended to do. Okay. All right. So what is the demand load of, and when you hear the word demand, that means you're going to have to do some type of calculation. Okay. Connected load would mean you just take face value. If you see demand load on an exam, you got to do something. Okay. You just should know that. So what is the demand load for the service for 2 3.5 kW wall-mounted ovens and 1 5 kW counter-mounted cooking unit? All of the appliances are supplied from a single branch circuit and are located in the same room of a one-family dwelling. Okay. Similar. Okay. But the difference is what? It's a load calc. We're trying to find the demand. But don't stress it. Try to work this question out. It's A, B, C, or D. Now, to get there, let me get a pencil. Let me get my paper too. I like to get my little notes here and do the same thing as you. Okay? So the first thing that I have to do is realize that we're doing a load calc. All right? That's the key. And I'm dealing with what? 2 3.5 kW wall-mounted ovens and 1 5 kW counter-mounted cooking unit. So we already know we're in 220.55. We got it. We know that. So I'm going to write down so that I don't forget. I'm going to write, I've got 3.5, and I got a 3.5, and I got a 5. Okay. Let's see with some answers coming in here. Let's see what you got. You can go to 220.55. I'll stay right here so you can read the question, so you can look back and forth. But I want to see how you can calculate the load and what's going on with the load. Okay. All All right, Alfie's got an answer on the board. Don't y'all cheat and look at the answers. We don't know if that's right or not. I will tell Alfie that is not correct, to give him an opportunity to relook at it, because I don't want you to sit and stew in it while we're looking up. Give it another shot. That's not right. So think about it a little bit more. And I'm looking at my 3.5, 3.5, and a 5 and thinking what I got to do. Okay. Just remember. All right. Now Jeff says D. Okay. Oops. There you go. There you go, Jeff. All right. So Jeff says you have the answer, but don't trust Jeff, even though he's very trustworthy. Go on and try to figure it out. I want you to really work it out and see how you came up with it. Okay. All right. Now I've left it on here long enough, so I will now go to that table so we can work this thing together. Okay. So I'll go to the table so we can work it together. And let's see here. We'll go to the top and we'll go to 220. I get to spin in the mouse and it just goes. Okay. All right. So what do we have? So this is the demand. So the table itself is dealing with demand loads. And you know, and here's how I tell people. I say, look, first thing you have to do, you have to realize is when you get a question that asks about a demand, and even though it says branch circuit in there, your mind needs to say, screw note 4. It's irrelevant because it's not asking me about a branch circuit loading. Okay, there's my little tip for you. When it says give you the demand load for it, and it didn't ask you for anything to do with sizing the branch circuit and anything like that, then you know that you're going to use table 220.55 no differently if I had 3 different cooking appliances, and because that's what you've got. You got 3 different cooking appliances. Okay? All right. So let's kind of work this out. Now, first things first. Notice, let me make sure y'all can see my screen, everything that I can see. Yes. Okay. Sorry about that. Just want to make sure you can. All right. So notice that this says column C to be used in all cases except as permitted in note 3. Okay. First thing that you notice, right? First, not that I noticed, but it should stick out a little bit. Okay. Maybe a little bit. All right. So here's column C. Right. And you've got all these notes. Okay. Now, first question I'll ask you is note C applicable? Okay. Because we've got what? We've got a cooktop, what do we have? Daggone it, I can't remember what we have. Hold on, don't y'all do it, I'll go look. We have 2 3.5 kW wall-mounted ovens and 1 cooktop that's 5 kW. Okay, you with me? All right, so I've already looked it up. So ironically, all of those fall here over 1 3/4 kW through 8 3/4. And that's 3 separate appliances. Okay. Now, ironically enough, see how we're at 3.5 and 5. They all fall under column B. Right? See that? 3.5 kW through 8 3/4, but ours was 2 3.5s and a 5, right? So column B is very much applicable because the general rule is to use column C for anything else except when note 3 applies. Remember that. Use column C for anything else unless note 3 applies. Well, what does note 3 say? If the appliances that we're dealing with are over 1 3/4 but not over 8 3/4, which ours aren't, they're 3.5, 3.5, and a 5, it says in lieu of the methods provided in column C, so this is telling us to ignore column C for a second. It says it shall be permissible to add the nameplate ratings of all household cooking appliances rated more than 1 3/4, but not more than 8 3/4, and multiply the sum, that's adding them up, by the way, by the demand factors specified in column A or column B of a given number of appliances. Now, just for craps and giggles, if one of them fell under column A and one fell under column B, I can apply the rules to column A. I can apply the percentages and the rules to column B, and then I can add them together. Okay, but we got lucky this time. It all falls under B. Now, one thing to remember: we always still have to compare our results to column C, because this is a permissive rule. This is permitting me to use the method that we're talking about here. It's just permitting me to use column B and column C under this rule in note 3. It's not demanding it. It's permitting me to use it. Could I use column C and just walk away? Absolutely. But I have to compare the two, and what do? I take the one that results in the lowest value. Okay? So if I were to take it just and say I had 3 appliances, because I really do, don't I? I have 2 ovens and 1 cooktop. I could go with 3 appliances and go right over here under column C and just take 14 kW and add that to my load calculation and just be happy. But I don't have to, because I always want to solve for the best and the lowest possible choice. In the real world, you might use the 14 kW. I wouldn't. I would use what the code allows me to use. So let's use the code, and we'll compare it to that 14. So since everything falls under column B, remember what it said? Take the nameplates, add them up, and then apply the demand factor. So here we go. What did we have? We had 3.5 plus 3.5 plus 5. How many is that? That's 12 kW, right? That's for 3 units. Now, what does column B tell me I can do? 55%. Okay, so 3 units, 55%. So I'm going to take that 12 times 55%, and that gives me 6.6. All right, so now we'll go back to the question. And I can already tell you this. 6.6 is better than 14. It didn't take me but a second to realize that, right? And that's how it is in the exam. You might not even have to do all the math. Once you see that immediately that the C column was so high, then you could just say, forget it. In the real life, you still want to compare the two. But 14 gets kicked away, and we're using 6.6. Okay, so the answer is obviously D here. On an exam, be careful again. They might want it in watts. They might want it in VA, which are synonymous. For example, 6.6 kW is the same as 6.6 kVA, which is also the 6.6 is the same as 6,600 watts, which is also the same as 6,600 VA. And most of the time, we break everything down into VAs, unless the question asks you otherwise. In this question, obviously, everything was in kW. So you just answered in kW, okay? Just kind of questions that you need to make sure that you get, that you get right, okay? You don't want to run into something like that. All right, what I want to look at is this one. Let's see, which one do I have written down? Is the number, yes, number 6. Okay, so this one routinely, for some reason, students get this wrong because they round it. Now, you're always taught what? That if something is 0.5 or greater, you round up, right? And anything that's under that, you can drop off. Not when I'm doing a load calculation for a neutral and the question's asking me what the actual neutral contribution is. What is the value? If the value is a certain amount, rounding it up is not really the amount. You with me? It wants to know, the question wants to know the actual amount. And so be careful with rounding. If it's asking you for the total contribution of something, it wants the exact value. Okay. Most any other time you're going to do rounding, but in this case, This is where most of the students get this one wrong. So let's look at number 6. So I have a 4.5, okay, for those that are following along. I have, let me make sure that that's what page we're on, that you can see it. Yes, you can. Okay, so I have a 4.5 kW, 240 volt electric clothes dryer, and it contributes blank amps to the neutral load when calculating the service by the standard method. Standard method. Okay, so first things first, what do you think? Okay, what do you think we use there? Are we going to use that 4.5? Remember, it's a standard method. Somebody tell me what part in 220 deals with the standard method. Is it part 2, part 3, or part 4? Which one is it? Let's start with that and see what we got. Try again, Elwood. Try one more time. You only have 2 other options now. Hey! Ding, 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 ding. There you go, Elwood. You got it right there. Okay. All right, so part 3 deals with standard calculations. Now, I'm going to give you another quiz. I'm going to test you. What section deals with dryers in part 3? What do you think? No. What? Let me say it differently because I'm going to screw you up with that. What section deals with dryers? Okay. This is the easier way to say it because I'm going to show you why I screw you up here in a minute. So, yes. So, Felix. Okay. There you go. So, no, Alfred, I don't know where you get that one at. That's a little bit off on the numbers of the articles you're in. That's grounding and bonding. Okay, I have enough people that answered it. So 220.54. Very good. So we have the standard calculation, which is part 3. But then we have all of the nuances that are in the other various parts when it comes to doing the ranges and dryers. So 220.54 is indeed where we want to be. So 4.5 kVA, we're doing the standard method. So one of you tell me, what is the VA that we're going to use in our calculation? Is it 4.5 or what is it going to be? And I'll just kind of wait for y'all to tell me that. Very good. Moise, thank you. Moses, I'm not sure how I say the name. Hopefully I'm saying it right. Maybe not. How about Fuentes? That's probably better. I'm probably saying that better, Fuentes. So anyway, okay. So, yes. Anytime you do the standard method, it's going to be 5,000 VA or the nameplate, whichever is larger, right? That's where we're going to do that. Now, that's only the first part of the question, right? So we want to solve it. So here, since this is what gets people. Since we're talking, and there's 2 ways to do this one, and I'll show you maybe both ways. It wants to know what the contribution is in amperes, not the contribution in VA. But again, if you know 240 volts and you know Ohm's law, then it's pretty easy to do the equations, right? Okay. So let's kind of work that. So I'm going to go to the code book real quick because again, I always like to show the code book and the reference on where we're getting all our info. And good news is we're almost right here, so we don't have to go a whole long place. Okay, so here we are. And notice that this is, again, section 54. And I'll remind you that section 54 is up under. So you got part 1 is the scope or the general rules. Okay, and then you go down. And you'll see where it switches. And I have a heck of a time with this version. Hold on here. I'll find it. Right here. Okay, so part 2, that's branch circuits. So standard calculations, part 3. But standard calculations use all of the data that we calculate under part 2. kind of interesting. Standard method just compiles everything. But all of the meat and potatoes of the work is done under part 2. Okay? And that might have been what you thought it would, so it's all good. All right, so let's go down here to what it says. Right here. The load for household electric clothes dryer in a dwelling shall be either 5,000 watts, or as you see, VA, or the nameplate rating, whichever is larger. Okay? So, whichever is larger. So, in our case, we only had one, and we're trying to find the contribution. So, we already know we're going to use the 5,000. Okay? Now, what's interesting about this one is it's asking me about the amps contribution. So, before I look up do I do that math, I need to know something else about neutrals. Since I'm sizing the neutral, what code section do I utilize in the code that tells me, can I have a reduction on that neutral from whatever the actual VA is going to be when we do this calculation? Okay, so anybody tell me what section has to do with neutrals, and can we do a reduction on this? Okay, still under part 2, still dealing with neutrals. Okay, actually, scratch that. It's under part 3, but it's still dealing with neutrals. So where we at? No, Elwood, no. Okay, very good, Jeff. All right, so Jeff gives us and tells us that it's going to be over in part 3, but it's going to be dealing with neutrals because we're doing a calculation, right? So we use branch circuit sizing and everything is under part 2. Under part 3, we do the standard calculation. But you remember, we have to use the standard method to do any neutral conductor calculating. We can't use the optional. So we're going to be stuck in part 3 for that. Okay. So we got guidance from part 2 in 220.54. We know what size VA we have to have for a dryer. So we're done with part 2. Now we're going to run over into part 3 and we're going to go to 220.61 and see, okay, do I get some kind of a break for the neutral current in this? Because generally, if you think about it, the dryers are 240 volt appliances. Why do we have a neutral? That's because sometimes the motor inside of the dryer might be 120 volts, so you need a neutral. Same with ranges. You might have the timers and some of the lighting and everything on it are going to be a neutral. So you have a neutral. But the good news is we get what's called a permitted reduction. That's absolutely right, Felix. So let's go to 220.61 and then we'll put all this together and I'll show you 2 ways to do it. This one, more than likely, in some form or fashion, will be on an exam questioning if you know how to utilize the reduction of a neutral. So just kind of bear with me. Let's go back over to the code. And I'm going to go to 220.61 right here. So we're doing feeder and neutral loads. All right. And we're trying to get a permitted reduction here. Okay. All right. So in our case here, it says under 220.61, and also you can find this in the back of the book as well under neutrals, as well as under, I believe, feeders. And there's many ways to find it, but again, once you find it, 220.61b, we're trying to determine whether or not we can take a reduction. It says, a service or feeder supplying the following loads shall be permitted, it's a permissive statement, to have an additional demand factor of 70% applied to the amount of 220.61b1 or portion of the amount of 220.61b2 determined by the following basic calculations. Okay, so we have a 1 and a 2. 2 is only going to apply to the service itself, okay, or feeder itself when I have neutral current that exceeds 200 amps, okay? So it allows me to, that amount that exceeds 200 amps, I get to multiply that by 70%. See, here's your 70% right here. Okay. So if I had a neutral load calculation, if you're doing an exam question and you calculate the neutral load on a dwelling or a building or whatever it is, and it comes out to be 270 amps. Okay. The first 200, you take it at 200. Okay. The remaining 70, you would take it 70%. and that's what you add to the 200. That's what number 2 is. But we're talking about a electric clothes dryer, which is right here. So here's what it says. It says a feeder or service supplying household electric ranges, wall-mounted ovens, counter-mounted cooking units, and electric dryers where the maximum unbalanced load has been determined in accordance with table 250.66. Whoa, sorry about that. For ranges and table, daggone it. Table 220.54 for dryers. That's what we used. We used the dryers. Okay, we're going to use the tables. Okay, if we were doing the tables and now that. We don't need to worry about that because we know what a nameplate is. We're just trying to solve for the amps. We just need to know that we get to apply 70%. That's what we get. Now, if you go up here and look at the dryer table here, 54 right here, it doesn't really matter because one dryer is 100% anyway. So that's why we're taking the full value of it at 5 kVA. Okay. All right. So let's get back to me and let's work this puppy out and end it because I'm wanting to know amps, not VA. That's where it gets you on an exam question. It wants to know the amps. Okay. All right. So what's the first thing we do? Get your calculator. Pretty simple stuff here, guys. So it's 5,000 divided by 240, and that equal, 5,000 divided by 240 equals 20.83 amperes. Then you just take the 20.83 amperes times 70%, and that is 14.58 neutral amperes. No rounding, folks. For all of you that are in the Fast Tracks program, at least Jeff, he knows, there is no rounding when it comes to, it wanted to know what the actual contribution is, right? And that is the contribution, 14.58. Be wary of questions like that on an exam. Give them what they want, okay? That type of thing. The good news for my Fast Track students, and I share this with people all the time, and I want you to know this. And it could be anything, even not my Fast Tracks, but I really want you to know this. Our questions like this that do not have a multiple choice are the hardest questions. On an exam, they give you multiple choice. All you have to do is process of elimination. If you do really well on our Fast Track competency reviews and you're getting 85% and greater, you're going to have no problem with your exam because these questions are tougher than many exams out there. Okay. So, it's kind of one of those things that, once you get used to it, you're going to get better. That's why the Fast Tracks program is so successful. But it's only successful is if you stick to it. And if you get a score that's less than 85% and I tell you, go back and do more reading, you need to go back and do more reading. I'm doing it for your benefit. Trust me. I've done this for many years. I want you to succeed. If I give you a bunch of feedback, it's for a reason. Don't take it personal. I'm trying to help. Okay. All right. So anyway, there's our answer for that one. The contribution in amps is 14.58. Okay. Because we had the beauty of being able to take a 70% reduction. Let's see here. Let's see if there's another question in here that people tend to get wrong a lot. I'll do one more before I go. Let me find another one real quick. Hold on. I'm looking for my notes because when I do competency reviews, when I read your stuff and I'm grading it, I make notes of which questions are the tough ones. And I've got a lot of them, but I need to see if I can pick one. And there was one that I remember that really gets people, and I want to find it real quick if I can find it. Bear with me, guys. Take a chill pill for a second. Take a break, relax, maybe get some wine, be last one, but let's see here. Ooh, that's a tough one too. I don't know if I could do that one. What do you think, Tim? You remember any of your tough ones that you think people really need to? I mean, all of them are tough. I'm going to tell you right now, Unit 8, 9, 10, 11, 12, and 13 are flat out. They ain't no joke, okay? Oh, I got one. Unit 13. Okay, we'll end on this one. This is not an easy one. Okay, but it makes you think. All right, let's go to unit. Let's see the Fast Tracks program. It's got everything in here. Let's go to unit 13. Okay, non-dwelling unit calculation now, folks. Okay, review. All right, I am interested in number 18. Okay, all right, y'all with me? So number 18, this one right here, could be on an exam. I'm just saying. So let's kind of give this one a work here. Y'all should be able to see it on the screen. And so it says you have a restaurant and it contains commercial kitchen equipment. It has one 12 kW range, one 2.8 kW mixer, one 4.2 kW deep fryer, 2.8 kW, there's two of them now, soup wells, no soup for you, and one 6 kW water heater. What is the feeder demand load in kW for this equipment? Okay, so I've got all this equipment in the kitchen and I have to size the feeder. I'm not worried about anything else. The question only is concerned with this kitchen equipment. Give this one a thought. I'll help you. Don't worry. I'll help you through it. But I want you to give it a little bit of a look-see here and see if you can't solve it. Hey, I noticed that some of the stuff did come through on the over on the Facebook. So again, thank you all for testing it out and let me know it's working. I see Yanni. I see Shaylay, Daniel. I see, yeah, thank y'all. I appreciate it. Jose, okay, you're over on the other one. Okay, thank you, Jose, for testing it out for me. I haven't used the Facebook one in a while, and I didn't know whether or not they fixed the streaming or not for that, but it looks like it's worked. So good. I'll just give us more options to study in the future. So there you go. All right, so looking at this question, what do y'all guys think? First things first, if you're preparing for an exam and you get this on a question on an exam, okay, it is other than dwellings. Dwelling is gone. And what does that mean to you and me? That means don't worry about 220.55. It makes no sense. You can't use it. Don't worry about anything. You got to be in another specific code section. And it's very close to 220.55. And I hope I didn't say 250 earlier, sorry. It's close to 220.55, but it is not 220.55. Tell me what section this one's going to be working around. So help me out, y'all. I really want you to get this question. So I'm going to do it with you. Okay, got my trusty pen. Okay. You know what's funny is I bought like 5,000 pins 5 years ago, and I bet I still got 3,000 of these things. I used to give them away at seminars. No, Elwood, we don't want to go there. We're not doing an entire restaurant. We're just doing the feeder for the kitchen equipment. Good thought. Not where we'll go. We'll do that one. We'll do one of those in a minute because I can guarantee you in many state exams like Texas, you will need to understand how to do 220.88. So if we finish this one pretty quickly, we'll go do one. I'll give you another example of a calculation there. At least make sure y'all understand how to use the optional method for restaurant calculations because it could come up on an exam. Okay. So answer this question, somebody. Code references that I see in there are correct. You're absolutely correct. I do see code references except for Elwood. Okay. I love teasing Elwood. Okay. I do see some answers coming in. All right. I see at least one answer coming in. So again, it does apply to 220.56. That's absolutely correct. Okay. So first thing I want to do is I got 12 I got a 12. Let's add these up. I got a 12 kW plus, and then I've got a 1 2.8, so it's 12 plus 2.8 plus 1 4.2, so it's plus 4.2 plus 2.8s, right? So it's plus 0.8 plus 0.8 plus 1/6 kW water heater, okay? Plus 6 kW. All right, so add all those up, and I see some answers coming in. I'm very, very pleased with the answers. So it's 12 plus 2.8 plus 4.2 plus 0.8 plus 0.8 plus 6. Okay? So that's 26.6, right? So what does 220.56 say that I do with those appliances, that number? Let's go to the code real quick, because we know our number is 26.6. So let's go to the code, and Elwood, that's not right, but you're getting there. So let's go to the code, and let's go here, right here. Okay, it says, it shall be permissible to calculate the load for commercial electric cooking equipment, dishwasher, booster, water heaters, heater and water heater, and other kitchen equipment in accordance with table 220.56, that's this table here. It says the demand factor shall be applied to all equipment that has either thermostatic control or intermittent use as kitchen equipment. These demand factors shall not apply to space heating, ventilation, or air conditioning equipment. Now, on an exam, don't get into the weeds on whether or not you think one of the things that they list or not is thermostatically controlled or intermittent. It's irrelevant. A water heater is thermostatically controlled. All of the items that are in the list are going to fall into that. Don't overthink it. Okay, they're not assuming you're an expert on appliances, that you know this or that. They're going to have to tell you. Okay, so assume that they're all thermostatic controlled, or intermittent use means you're going to use it a little bit here, a little bit there, which probably qualifies a lot for most all kitchen equipment anyway. So how many units do we have? We have 1, 2, 3, 4, 5, 6. So we have 6 or over. I can apply a 65% demand factor to that 26.6. So let me take 26.6 times 65%. And that equals 17.29. Okay? 17.29. Now, it also goes on to say, so far we think the answer is 17.29. And I can promise you on an exam when it's multiple choice, 17.29 is probably going to be one of the answers that they put there to try to think you're going to go, oh crap, that's the answer. I'm going to check it. Stop and think and really look at the code, because it goes on to say this. However, in no case shall the feeder or service calculated load be less than the sum of the largest two kitchen equipment loads. Okay. All right. Well, you're sitting there saying, well, what are the two largest kitchen equipment loads that I'm dealing with in here? Okay. All right. So let's see here. The largest is let's go back to our code. Let's go back to our question. So at no point can it be less. So you might think again that 17.29 is the answer, and you're like, I'm done, Paul. Let's squeaky clean. Let's go on to the next one, because you know the answer is going to be there. That's why it's so important under our fast track stuff. You got to answer it. It's hard. So in this case, no less, it can't be less than the two largest pieces of equipment. So we had a 6 kW, and then the other one is the 12 kW. So it's 12 plus the 6 is 18 kW. It's not 18 point anything. It is purely, it's just 18. Okay? And that's the answer. 18 kW. Okay? And the reference for code, again, would be 220.56. Just that simple. Okay. Okay. Let me go real quick and do that one that I wanted to show you for ranges before, because again, I could go on forever, and I'm always teaching you how to look things up. So I figured tonight I wanted to do, a little bit of calculations and some of the, just to make you think a little bit. Obviously we could go on for hours, but I don't have hours. So let's go back to the NEC real quick. And I want to show you this because, again, in case it comes on the exam. All right, this table right here. Okay, so very common on an exam. They'll give you a specific KVA because, again, the only way you use this optional method for a restaurant is that an engineer has designed out and added all the loads up under this optional method, all of the connected loads, because if you read 220.88, it says calculation of the service or feeder load where the feeder serves the total load for the new restaurant shall be permitted in accordance with table 220.88 in lieu of part 3. Well, I could calculate this up under part 3, but it says I can do this in lieu of it. Okay? So if that's the case, basically, what does it mean? It means that the engineer is going to take all of the electrical loads. See the note down here? He's going to take all of the loads in the building at their face value. He's going to, and then nameplate values. He's going to include both the heat and air conditioning. He's not going to do this or that. He's going to conclude it all. And he's going to add all of these loads up together. Then you're going to select one demand factor that applies for the table, okay? Then multiply the total connected load by the single demand factor. Okay, so an engineer gives you, so on an exam, okay, you with me? On an exam, what they're going to do is they're going to give you the VA, the total amount. That's what they're going to give you, right? And so what they're going to say is, I'm going to give you one to work out. I'm going to let y'all do it. I'm going to tell you that you have a 475 kVA all electric range. Now, by the way, for those that say they're not all electric, it's just like it sounds. It's not all electric means that there are other gas appliances in here, so you do have some allowances under that. But most of the time, they're all electric. And on an exam, more often than not, it's going to be an all electric calculation. Okay, so I gave you a value, folks. I need you to tell me what the optional demand factor is, or what the optional demand load is for that. It was 475 kVA all-electric restaurant. Using this table, tell me what my load is. What is my actual calculated load? Work it out for me. Remember, I told you 475 kVA. Okay, work it out. Let me know what you get. Give me some numbers down here. I'm going to work it too. Dude, this one's important. I really hope you get this one. A lot of people don't teach this one, but we want to do it. So I'm going to do it myself. And let's see here. So it was, okay, so I've got, work it out and give me some numbers, folks. Okay. All right. I'm going to work it out too. And see what you got. You know who I'm giving that applause to. That's one of my latest superstars in the program. All right, so work it out, guys. I know there's a lot of people. There's still 33 people on here. Don't cheat. Don't look at other answers. Really work it out. It's important for you to be able to understand how this table works, because a lot of people get this table wrong. And I will guess, Jeff, did you listen to my podcasts on this or one of my videos on this? Or did you just know it? Many people don't. But I've done podcasts and explained it in videos and podcasts that explain this table. And in some people, the table is straightforward. For many people, it is not. So I want y'all to try to do it. And don't look and cheat. I can tell you in Texas, the probability of this question like this being on an exam is very high. Okay, this type of question specifically, I don't know if it would be to the 475 kVA, but this is yeah. See, Jeff says it's straightforward. To many people, it is not straightforward. So let's see some answers, folks. Anybody got any answers? Again, don't look at the answers in the chat box. Try to figure it out yourself. Maybe you're still calculating them out. Give it a shot. See what you get. Still waiting. We're ending up on a good note, guys. We have 32 people. We were up to close to one time, I think, close to 100. Germ Bassin. Hopefully it's Bassin because I'm a bass fisherman. I love fishing. Not right. A little off. Go back and look at it again and look at it really close. Look at it really close, and it might be easy to understand. Anybody else? Again, we got a bunch of people in the background who are just watching. Don't be shy. Show us you know how to do the calculation, and don't look at anybody else's answer. Just type yours in there and be honest with yourself, because that's the only way you're going to learn. That's why Germ, I appreciate you, and I don't know if I say Germ Bassin. I appreciate you, because you want to come out there and you'll give an answer out there, because that's the only way that we learn. Okay, we all don't know it all. Okay, except for Jeff. Jeff has been pretty spot on tonight. Okay, I give Jeff my harp of the night. You ready? Oh, also, I should remind you that at any time you can subscribe, and if you enjoyed it and you want to make a contribution, there's a little money symbol there. You can click it and make a contribution. Anybody that donates over $5, I will send you a screwdriver or a flashlight. Okay, these are little, every little bit helps, but there you go. You don't have to, though. It's not a requirement to do so. Okay. All right. Giver's gain, I like to say. All right, so, and I also used to tell you, we use that to pay for things that we send people, but lately I had been using it to actually offset the billing that I bill to the corporation for the time, because they're donations, and again, it helps. Every little bit helps. All right, so we appreciate it. I'm like a panderer at the corner of your street light in your downtown city, who's always there waiting for something. You'll put a little in the hat. Okay. God, look at that. Look at that. No Elwood comments on that? Look at that. God, I swear. Anyway, boy, that's bright lights, man. I bet that blinded half of you. Hey, all crafts, thanks for coming. Appreciate you coming. All right. Oh, okay, cool. I love fishing too. My wife is a fishing freak. All right, I don't see any other answers coming in. So that tells me that people are struggling with this question. I'm going to make it simple for you. Okay, so remember what we said. Look at this question right here. So I said it was 475 kVA. 475 kVA falls between 326 and 800, does it not? Yes, it does. So we're going to be right here. Okay. Now, I have to apply 50% reduction or demand factor to the amount that's over 325. Exactly what it says. You always want to look at the parentheses first. So my value was 745. So I want to take it was 475. I was a little dyslexic there for a second. So it's 475 minus 325. Okay, so 475 minus 325, that leaves me 150. Once I have the 150, you take 50% of that number. Okay, that's where everybody goes wrong. It's not 50% of the 475, it's 50% of the number that is the amount over 325. 50 over 325. That's where some people get it wrong, and I guarantee I know students who get it wrong on exams, and they call me and they go, God, I missed it. So anyway, it was the 150 times 50%, so 75. Then you add 172.5 to that. So then it's plus 175.2. And actually, hold on here. I messed my daggone calculator up. Sorry. 475 minus 325 equals, okay, times 50%. I don't know where I got to that. Okay. So it's 75. Oops. Plus, and then you've got the 172.5. Okay. And that's where you get this 147. Yep. 147.5. And so that is what your actual, at your KVA. It's just, really is just that simple. And no matter what KVA they give you, it's the same way. Do the parentheses first. Do the parentheses first, and then apply this percentage to whatever it is, the amount that's over whatever it tells you here. And then you add this value to it. And that's your total. Now, after I've shown that to you, doesn't it seem totally correct? Elwood, it wasn't really, I didn't have a question on screen. I asked you to give me what the actual optional KVA load was for a 475 KVA all electric restaurant. So you go to 220.88. You go to the connected load, which again, connected means the actual full value. That's all the things added up. That's what the engineer gave you, or on the exam gave you. It said it was 475 kVA. Choose which one you're in on the left column there on table 220.88. In our case, we were between 326 and 800. So then we go over to the column, and we're dealing with an all-electric all-electric restaurant. So we know we're in that first column. Okay, and it says the amount that's over 325, apply 50% to that, and then add 172.5 to that. Okay, so in our case, we did that. We took 475 minus 325, so the amount that was over 325 was 150. We took 50% of that 150, and then we added, like it says on the screen, we added 172.5 to that 75, and that's how we got 247.5, and that is the answer. And if you think about it, that is huge, because it went from 475 kVA, which is a big service, it went down to 247.5 smaller service. So for that all-electric kitchen. You know what I'm saying? Yeah, I couldn't remember, Elwood. I don't know. I thought it was you that asked me to do it, or you had posted about 220.88. So I just wanted to jump to 220.88 and at least do a kind of a question on that table, because again, I see that table on exams a lot. I just do. I don't know why they asked that range restaurant question. Half of you probably, or 90% of you, will probably never do a restaurant at all. Or the engineer will size everything for you. Anyway, that's it for tonight. I think we put 2 hours in tonight. Check us out next week. I will hopefully have some more calculations for you, as well as some more code questions that we'll look up. We will do our best to teach you. If there's anything you want me to teach, email me. And we'll do it on one of these nights. Again, you got to give me feedback. If you say, well, Paul, do this, give me something this, show me how to do this, then give me that feedback and I will do it. And just send me an email, info, I-N-F-O, that's I-N-F-O, at masterthenec.com, and say, hey, Paul, could you talk about this, or could you explain this? And I either will email you directly, or I might use it in one of these live streams, right? Whatever helps you learn. I'm here to help you. I want to be a servant to you and help you understand the code and reach all the goals that you want to reach in life. And for everybody that purchases our training programs, thank you very much. We appreciate you. You have no idea how much. And order our P tabs. If you like them, let us know. They're very basic, but they're great little tabs. So anyway, that's all I got for tonight, guys. I'm tired. It's been a long day now that I'm actually back in the office working full time. I get tired easy. I don't know if that's just because and I will say that I was up last night till after 1 o'clock, and you probably all know why. And I'm a little disappointed, but it is what it is. Okay. We shall all come together, and that's what we do in America. So let's move forward, baby. All right. I appreciate all of you. God bless. Till next time, stay safe.